Circles and trigonometry. Before starting this video, make sure you have reviewed Circles and Trigonometry Part A at the website given below. In Part A, you explored how to determine the primary trigonometric ratios for angles that were in the quadrant 1. In Part B, you will now explore how to determine the primary trigonometric ratios for angles in all 4 quadrants. Here's a problem that we're going to use to walk you through the steps. Find the radius of the circle passing through the point -5, 12. The measure of the angle in standard position for the terminal point P at -5, 12. State the primary trigonometric ratios for this angle in exact form. We should do this on graph paper if you have it available. Start by making the sketch. Start by making the X and Y coordinate system. Plot the given coordinates P at -5, 12 on the coordinate system. Draw the terminal arm and label it R. Add the reference angle theta. This is the sketch we will use to determine the value of R. Now, we have x equal -5, y equals 12. We have a right angled triangle formed between the x and the y value, and the r then can be calculated using the Pythagorean theorem. R squared equals x squared plus y squared. If we simplified that one step further, r is equal to the square root of x squared plus y squared. Substitute in -5 for the x. Please note that it goes inside brackets, plus 12 squared. We do the math and we get the square root of 169, which is 13. Find the measure then of angle theta. You are given the x value, which is adjacent to the angle. You are given the y value, which is opposite to the angle. Therefore, we can use tan theta, which is opposite over adjacent, which is y divided by x. The tan of theta is equal to opposite over adjacent, which is y over x. So we will take the y value, which is 12, and divide by the x value, which is -5, which will give us -12 over 5. On your calculator, use the second function tan of -12 over 5 to find the value of theta, which is 67.4, rounded to 1 decimal place. You have one more step. Since the angle is in the second quadrant, you must subtract this measure from 180 degrees. So 180 degrees minus 67.4 will give you 112.6 degrees. Just to review, the 3 primary trigonometric ratios in exact form. Sine theta is opposite over hypotenuse, which is y over r, which is 12 over 13. Cos theta is adjacent over hypotenuse, which is x over r, which is -5 over 13. Tan theta is opposite over adjacent, which is y over x, which is -12 over 5. The rules that you need to follow are: in the first quadrant, sine has a positive, cos has a positive, tan has a positive value. In the second quadrant, sine is positive, cos is negative, tan is negative, and you need to subtract 180 degrees minus theta. In the third quadrant, sine is negative, cos is also negative, but tan is positive. In the third quadrant, you need to calculate the angles by taking 180 degrees plus theta. In the fourth quadrant, sine has a negative value, cos has a positive value, and tan has a negative value. We need to subtract the angle from 360. There's a four-letter word that we can use to remember the signs, and it is C-A-S-T. This rule is called the cast rule. C for cos, A for all, S for sine, and T for tan. On to the next video in this series, Circles and Trigonometry, Part C.